It's the start of another day at my restaurant, and I'm gathering the freshest ingredients before I begin cooking. Oranges are great to add tang to any dish.
Oranges are tangy because of the acid they contain. In fact, the word acid comes from the Latin word acidus, which means sour. By the end of this lesson, you will be able to define an acid, define organic and inorganic acids, explain the physical and chemical properties of acids, explain how indicators help to identify acids, list the uses of acids. Any substance that releases hydrogen ions when dissolved in water is an acid. A hydrogen ion cannot exist on its own, so it combines with a water molecule to form a hydronium ion. For example, hydrochloric acid when dissolved in water liberates a hydrogen ion and a chloride ion. The hydrogen ion combines with water to form a hydronium ion.
This curd is too sour. It needs a little sugar.
Curd contains lactic acid, which gives it a sour taste. Acids obtained from food like curd, lemons, grapes, raw mango, citrus fruits and gooseberry are called organic acids. Hydrochloric acid, sulfuric acid and nitric acid are called inorganic or mineral acids. We already know that acids taste sour. Acids also have other physical properties. Acids turn blue litmus red. They also turn methyl orange red. Acids have a corrosive action on the skin. Sulfuric acid stains the skin black. Nitric acid stains the skin yellow, and hydrochloric acid leaves an amber stain on the skin. Acids are good conductors of electricity. Let's try to prove this through an experiment. Pour 5 ml of hydrochloric acid into a beaker containing 10 ml of water. Suspend 2 carbon rods in the acid. Connect the rods with an electrical wire in series along with a battery, a switch and a bulb. Switch the setup on and see the bulb glow. This shows that acids are good conductors of electricity. Mixing an acid with water reduces the concentration of hydronium ions of the acid per unit volume. This is called dilution of acid. Acids generate heat when they are diluted. This is because the action of acids with water is exothermic. Take 5 ml of water in a test tube and carefully add sulfuric acid to it. Now shake the test tube and touch its base. The base will feel hot, indicating that a reaction between acid and water is exothermic.
I never store tomato soup in a copper pot for very long. It gives the soup a funny taste.
Tomato soup, being acidic, reacts with copper, and that is what causes the change in its taste. Acids react with metals to form metal salts. In this reaction, hydrogen gas is liberated. Take a few granules of zinc in a test tube. Add 2 ml of sulfuric acid to it. You will find that a gas will be liberated. Bring a burning splinter close to the gas liberated. The splinter burns and a pop sound shows the presence of hydrogen. Acids react with metal carbonates to form corresponding salts, carbon dioxide and water. Try this experiment. Take 1 gram of magnesium carbonate. Now pour 2 ml of hydrochloric acid into the test tube. You will observe that a gas evolves. Pass this gas through freshly prepared calcium hydroxide solution, also known as lime water. Lime water turns milky, proving that the gas is carbon dioxide. The precipitate formed in this process is calcium carbonate. Acids react with metal hydrogen carbonates and form corresponding salts, carbon dioxide and water. Take 2 grams of sodium hydrogen carbonate in a test tube. Pour 2 milliliter of hydrochloric acid into the test tube. You will see that a gas evolves. Pass this gas through freshly prepared lime water. The lime water turns milky, indicating that the gas evolved is carbon dioxide. A white precipitate of calcium carbonate is also formed. Acids react with metal oxide to form salt and water. Let's conduct an experiment to prove this chemical property. Take 10 milliliter dilute hydrochloric acid in a beaker. Add 2 grams of copper oxide to the beaker. Stir the mixture continuously. You will find that the black copper oxide disappears and a blue-green solution is formed in its place. This blue-green solution is copper chloride. An acid-base indicator is the one which exhibits different color in acids and bases. Red cabbage is a visual indicator used to detect acids. The cabbage leaves are purplish in color but turn red in the presence of an acid. Onions are called olfactory indicators because of their characteristic smell. This smell is destroyed by the action of a base. The most common indicator that you may have come across in the laboratory is litmus, which can be in the form of a solution or paper. Litmus is a natural indicator and is extracted from lichens. It is dyed blue and red to detect changes in color. Take 1 milliliter of any acid and put it into a watch glass and then place a red litmus paper in it. There is no change. In the same setup, place a blue litmus paper and see what happens. The litmus paper will turn red, indicating the presence of acid. This shows that acids turn blue litmus red. Apart from natural indicators, there are a few synthetic indicators such as methyl orange and phenolphthalein. The neutral color of methyl orange is orange and it turns red in an acid and yellow in a base. Phenolphthalein is colorless. It does not change in an acid but turns pink in a base. Acids have various uses. Sulfuric acid is used in the manufacture of fertilizers, paints, dyes, chemicals, plastics, and synthetic fibers. It is also used in car batteries. Nitric acid is used in the manufacture of fertilizers, explosives like TNT, dyes and drugs. Hydrochloric acid is used before galvanizing to remove oxide film from steel and also as a descaling agent for boilers. It is also used in the textile, leather and food industry.